Hello, today I'm going to talk a little bit about solar systems, and like I promised in the blog, let me start off by showing you how you calculate the capacity for a system. There are two items you have to calculate capacities for the solar panels themselves to determine how much you want to generate, and the capacity of the battery system you want for backup and any surge, and for bad days. And bad days are when it's cloudy or if there is snow and it covers up your panels. There are plenty of websites which calculate these for you, but I'm going to quickly run through some calculations so you at least understand what's going on with these. This is what I pulled out from my Pepco bill, and every monthly bill should give you this graph. Each of these bars here are usage per month, and this is in kilowatt hours. So this is power, which is kilowatt, times how many hours you use. What you're trying to size is your kilowatt of the system, so the rate at which you want it to produce power. As you can see, July is a high usage month for me because I run the air conditioning system. You could design the system for the worst case condition, but honestly, that would be overkill. You are relying on either batteries or being tied up to the grid to take care of any surges. And remember, even within a month or day, there's going to be variations. It's not going to be a flat line. So you design for the average use and then rely on the backup battery or the grid for any surges. If you look at this graph, it's about, let's say my average usage is 300 kilowatt hour. For ease of calculations, I'll call it 240. And if you don't have this graph, this is from Pepco. I have Pepco as my supplier. You should have this entry for every month. So this is 350 here for 31 days. And you will have to go back and pull out every month's bill and then chart it out to see what your average usage is. So coming back to this, so if 240 is my kilowatt hour is my average usage, you have to divide it by the hours, which is 30 days times 24 hours in a day. Instead of 24, I'm going to make it 8 because you really are not actively using it across those hours. So 30 times 8 is 240. So my usage is about a little higher than 1 kilowatt hour. Since I'm in Maryland, I'm going to double it to account for the fact that the sun is not going to be shining on the panels for 24 hours. So that's about 2 kilowatt hours. I would say about 2.5 because I approximated things here. So let's go to one of these websites. This is from Go Green Solar. I'm not recommending any of these guys, but it's just some companies which are really good websites which I'm using. You should shop around and look at online reviews. And by the way, I know there are a lot of myths floating around that solar panels are not as efficient. It's like cars where your fuel mileage is done under idealistic conditions, and that's not true. Assuming the sun is shining, the solar panels do work as they're rated. The problem is that you have to account for where you're locating these panels in which state and where on your house you're locating them. So here when you go to size your system, I'm going to put 240 here. Like I said, I need it for 100%. Let's see what it says for California. This is it, and they're recommending a little more for safety. So let's go to Maryland, and as you can see, this is going to go up. So it's almost, like I said, 2.5 kilowatt or 3 kilowatts. Now, how much do you want your backup battery to be? I would say at least half of 1 kilowatt to account for surges. So if you plug in, let's say, a power drill or you run a heater, you are suddenly going to use more energy. But honestly, I would put in at least 4 to 5 days of backup battery. So if my usage, I say, is 1 kilowatt an average, I would put 4 or 5 kilowatt worth of batteries. When we start designing our system, initially we are only going to put the minimum required, maybe 1 kilowatt, simply because we are not going to be living on the land for a few years till our whole house gets built. And by then, battery prices will have come down substantially, thanks to Elon Musk. His company did introduce batteries, but there was some hum and it was withdrawn. But it's only a matter of time before we have good, cheap batteries. And solar systems are one of the few things in life where prices are going down. The panels and the batteries are the most expensive parts of a solar system. And panels, you will never have to, you'll hardly have to change it, and they have a pretty long shelf life of about 30 years, not shelf life, operating life. So the only reason you might change it is because 10 years down the line, you have panels which are way more efficient. So what was I talking about? Capacity. Okay, so you can either design the system yourself, or you can get someone else to do it for you, or someone else to do the install, or you can design, others can do the install. If you are purchasing the parts yourself, you can either go the kit way, where you can get entire solar panel kits, and you can see the main components are panels, inverters, and the mounting hardware. Make sure you get roof mounting if you're putting roof, ground mount if you're placing it on the ground. You also get mounts which track the sun. That way, the solar panels are always facing um, the sun, and you're increasing the efficiency of the system. I just had a thought, maybe if I use, I'll be using ground mount. If I put tracking systems, I might just grow sunflowers on either side to see if they face the same direction as the sunflower. And maybe as an experiment, I could use an actuator. Actuators are motors which use low energy signals as the control signal, and they're active devices, so you need power to actually turn the motor. But it'll be interesting to see if the panels align themselves just like sunflowers. So where was I? Yeah, so you can get these kits, or you can buy individual parts. It might be cheaper. Just be careful when you buy these kits or parts, that if you're not connected to the grid, do not buy grid tie inverters. Grid tie inverters are only used if you connect to the grid. Most companies provide grid tie inverters because it's not legal. It's illegal in most states to be off the grid. So there is a bigger demand for grid tie inverters. You should go to a company, something like Backwood Solar, which also does off-the-grid systems. You notice I'm not talking about Solar City simply because their business strategy is different. They sell you the power, or they sell you the entire system once they design, build, and install it. They are not in the business of selling parts, as far as I know. Also, when you size your system, bear in mind as to what your usage is going to be. Our usage might be different on the land compared to, this power, because we are using things like rocket mass heaters and a fireplace for heating the house, but we might use room heaters a little more. Um, we have central um, if you have central heating, that consumes a lot of power. Anything with heating coils consumes a lot of power. So if you are heating your room, heating water, your cooking range, oven, dryer, which has a heating coil, even incandescent bulbs are inefficient. And these are the ones which use most power. So you should be switching to LEDs or CFL, compact fluorescent lamps. Again, as I said, our usage on the land might be different. We hardly plan to use the dryer because we can line dry our clothes outside. Where we live now, we are not allowed to do that. Small things like if your fridge is completely stuffed, it uses less energy. If it is an empty fridge, uses way more energy. Um, so before I end, I'd like to quickly talk a little bit about water heaters, solar water heaters. Since it'll be quite some time before we have our entire system up and running, we plan to install a simple solar water heater. I'm going to show you a photograph of a system. This is a system which was in Cobb Cottage in Oregon, where we went to do a Cobb workshop. Extremely simple system, black garden hose, and this is directly goes to the shower head. What this means is when the sun is shining, you have hot water. When it's not shining, tough luck. You could go a step further. I was thinking maybe use sensors which detect when the water is hot, and instead of piping this directly to the shower head, you put it into a water tank which opens when this water is hot, pours it in, and the water tank is insulated, and that extends the time. I don't know if it's doable. This is all ideas I have. What you could also do is what's called a heat exchanger, which is done pretty commonly, actually. So let me go and give you an example. This is a website from Solar City. So as you can see, that black hose on the other system, instead of going to the shower head, it wraps itself around this water tank, and the heat is exchanged, like the words, like the name, and the water inside this tank is heated up. You can design it such that the natural flow of the water um, is such that the section of the pipe with the hot water is around this tank. I don't know what happens at night if the heat flows the other way, but again, this is something we are going to consider. We haven't looked into it. As we design these, I'm sure there'll be a blog post we talk about, or you can always pull out enough information from the internet. This is a Solar Cities blog post, which is pretty good. The reason you use black cable is it's black hose, is because black is absorbs heat while white reflects it. In fact, when I bought my last car, I made sure the color of the car was as dark as possible. Black was not available, so I bought teal, which was the next closest dark color. Simply because I'm from a hot country, I'm okay with heat. In summer, I just roll the windows down, but during winter, I want my car to be as warm as possible. So just to conclude, if you are putting a solar system, first check with your county if you're allowed to go off grid. Then you need permits for your solar system, and that's separate from the permits for the electrical wiring in the house. Alan and I, are going to take the homeowner's exam for doing the electrical wiring in the house. That's just for the wiring in the house. You do not have to take an exam to do the solar system. And but you do need permits irrespective of whether you install it or you get someone else to install it. So hopefully that gives you a nice high level overview.